Hi everybody, and welcome to yet another field scouting video starring Jerome Lesemann, Vancouver Island University, and Gary Paull, U.S. Forest Service. The three of us are out here looking at a beautiful series of outcrops on
Open Bay, Quadra Island.
Open Bay, Quadra Island. Thanks for joining us. Let's get started. So we're at the beach, but this is really a bedrock cliff kind of outcrop, Brady, that I think we're talking to Brady Lawrence, the Seattle videographer, and we're using these field videos, viewers, to just give a bunch of ideas, visual and geology ideas to Brady. And then he watches these things, and he and I whip up a little script, or at least a loose plan. Oh my God, okay. You're 3 for 3, Jerome. Calling that right off the bat. Oh, Jesus. Okay. Right here.
Yeah,
Come
right
on.
here. We could stay here all day, almost. But there's more of this, and the theme is similar, but the variability is really striking.
Oh, wow.
So let's just start at my feet, and then we can sort of go from there. But at my feet, there's what we would call the limestone unit. But you can see that it's a mixture of different materials. There's black beds in there. There's oxidized ones that are all different. And the striking thing is it's all deformed. It's folded in from multiple directions.
Were these layers originally flat?
Yeah, or close to it. They would have been, most likely, originally somewhat horizontal and flat, and they clearly aren't today. And so there's fold. You can see a large fold at my feet. And the great thing here is that because of the coastal erosion, we're sort of seeing a bit of a platform, but we can just follow some of those folded units into a vertical face.
Let's do it.
Yeah, so let's just pick one.
What's our favorite?
Let's
I
pick
like
this
the double maroon.
there. Yeah, there we go.
Like mines. Come
I know.
I thought you were Canadian and I'm American.
It's
you mean we have the same?
It's too early for this. Too early for this.
Okay.
But let's follow the double. So that, we can follow it through here, and then it comes up over here. So now that fold structure, you can follow it here. Where does it go after? Well, it ends abruptly because in the middle of all this, there's an enormous intrusion.
Oh, geez.
So Gary is standing on.
Oh, cripes.
No, I couldn't stay away from it.
I know, you have to always straddle the. Yesterday it was.
I was trying to find granite yesterday.
Yeah, well, there you are. A granitoid or some sort of.
All right, so what's Gary on?
Granite is on some. Gary's on some kind of. Gary's calling it granite, but a granitoid of some flavor or some intrusive rock, an injection in this case probably, so a bit of a dike.
So
and
Gary's white rock has to be slightly younger than your black limestone because it cuts up through it.
It cuts through it, and it's quite, it's 3-4 meters wide. It goes right to the top of the face. There's folded limestone to the left of it. There's folded limestone where I am to the right.
You guys stay there. Keep talking. I want to get a wider shot of this thing. I don't know if we want to do that. Like for the episode, I thought it was just going to be folded limestone, but if there's a nice relationship.
But what you're seeing, look at your feet where you are right now. If you look down, you are standing on limestone and the same white rock or similar white rock, and that's folded.
I'm in a swirl.
Yeah.
I'm in a blender over here.
Yeah.
But then the white
cross-cuts that already. So there's multiple, right? You have to have the intrusion of the rock, but in some places that's already been folded. So there's a precursor intrusion.
All right. Well, we're going to ignore what's at my feet, I think. Like my first thought is we just have limestone cut by white granite.
Correct.
Has to be younger than the black limestone. Yeah. But the limestone is not passively just undeformed, it's also deformed.
Before the intrusion, yeah.
I mean, do you have your students come here and do you try to figure out how many generations of deformation there is?
That's it, exactly. And
it's like a 101 relative age dating thing. This cuts this cuts that, this cuts that.
Correct. except that it's a bit more complex than that because
Yeah.
the deformation happens from different directions at different times. So we have folds that get folded again, right? So you take your originally horizontal rocks, imagine you fold them, and then you can fold it again. So you take a folded rock that you refold. And in some cases, it seems to be almost orthogonal in terms of at right angles, the two different folding episodes. So in places we see folds that have been folded, if that makes sense.
So we had the first folding, then we had the granite come in,
In some cases,
and then we had that
then we had another
folded together,
folding.
and then we had another dose of
intrusion, potentially, yeah. And those relationships are not always that clear, right? And then the other, so here's a good example, right? There's a branching off of that main intrusion. There's a thin one. Gary's got his foot on it, but you can see the connection right here. So this is branching off of this,
Right.
and
It's squirting over here.
through here. And what you see is that it's also been somewhat deformed because it's kind of fractured. You see how that's been broken and dislocated into little blocks?
Yes.
This, right? So
Yeah.
it's sort of been stretched, but brittle, more brittle in its deformation here. And that's deformed at an angle that's different from the deformation that affected that limestone. So when we
Okay,
talk about
that's key.
episodes of deformation, there's multiple
Yeah.
rounds of deformation.
So we see two of them just right here.
Yeah, more, yeah.
So
At the very least, yeah.
here's a classic example of where I get off the boat mentally.
Yeah,
Like there's half a day of people on a geology field trip, all these professionals, and they're on their belly and they're working out all these, and they've got all their labels for all the boudinage and this.
yeah,
and that.
exactly.
And then at some point I'm like, I don't give a shit anymore. Okay, I want to zoom way back out.
Yeah.
And I want to do big picture stuff. Why is the limestone here? How much of it is there here?
Yeah.
Was there a warm, shallow sea over this part of British Columbia? How
Yeah.
old is it again? This is not 70. This is 225.
Something around that, yeah. Or maybe a bit younger because we're like near the end of the stacking of the Carmoutzen basalt, right? The eruptive, or maybe in the middle of it.
So let's talk about in this field scouting video and ideas for Brady. Is there more that we can kind of absorb going this way, or
Yeah.
is this kind of the sexiest?
No,
right here?
there's more. We can go that way. We'll see something a bit different, but we can walk that way. We can keep.
Well, so let's do that.
Yeah,
Let's walk
let's
a
keep
little.
walking.
Or is there more you wanted to point out right here?
Oh, there's tons more, but that's okay. We can.
Okay.
We'll see similar
Okay.
things a bit further.
So we were on the ferry coming over here to Quadra Island. We stayed the night at Campbell River. Had a beautiful dinner at
Right on the 50th.
50
parallel.
on the
north.
50th parallel, 50 degrees north. Gary kept taking photos. Like, Gary, food's ready. Got to come back over. So we've already been kind of talking about this, viewers and Brady.
Ooh.
And this, the shocking thing, I think, and the sexiest thing. Go ahead. Interrupt anytime you see something cool. Gary, what do you like here?
Well, I'm just kind of excited about this whole edge of the
Intrusion there.
intrusion here, coming into this swirly limestone that's got these. I guess those are iron.
Yeah, they're
kind of
very
iron-rich layers.
Iron-rich
And
layers.
here the orangish stuff, and then going back to gray.
Yeah,
White.
This commingling, this weird dance between injections and folding, and fold the injection and fold both of them now. But I think what we're leading to, and Brady, I think this has to be the biggest part of the episode. None of this is North America.
Yeah.
All of this limestone forming, all this folding of the limestone, even the folding of the limestone is out in the Pacific somewhere. It has to be. Let's just
Chat this
nail
out
that.
through.
It
Yeah.
has to be, right?
Yeah.
Nobody's saying that this folding is happening as you accrete this. This is exotic material.
I think that's an appealing idea, but I don't think the dates work with this.
The dates are too old.
Dates are too old for these, and also we don't exactly know where's the leading edge, or where's the edge of this insular part. It's often tempting to think that it has to be in the Strait of Georgia because that's kind of a
just
natural depression.
right over here.
Over there, yes. But, you know, how far does it go? How big is that block of insular? And there's a good chance that it extends way far to the east from here into the coast mountains. We saw on the map, we were looking at a map yesterday where there are little remnants of Carmoutzen basalt deep, deep into the coast plutonic complex. Like far east, when I say deep, I mean far east into the coast plutonic complex.
Dozens of miles from here, even.
Yeah. So where's that boundary? We don't know. Not sure. It does not have to end right where the plutons start because the plutons intrude. This is the key thing, right? It's an intrusive boundary. And so, and the dates don't really match up with the general idea, timing of the accretion. So this has to happen prior to all this.
Okay, so I'm imagining a viewer right now is like the fingers hovering over the stop button. I'm going to go on to the next one. I'm already lost. I don't know what some of this stuff means. Let's cut to it. This is limestone that formed in warm, shallow marine water.
Right. Around the same time as we're erupting Carmoutzen.
At the equator. It
Yep.
has to be the equator because this limestone was deposited on top of and within the top of the Carmoutzen basalt, which was in an oceanic plateau.
Oceanic plateau. We were using the Galapagos hotspot as a reference, as a potential source. And so at that low latitude, equator or not.
Equator. These are equator rocks from 225 million years ago that somehow found themselves. Okay, that's the biggest thing. I would be excited that we would have coral reef limestones out in the Pacific close to the equator.
Yeah.
But then to have it so complexly deformed, that's the biggest part of this to me right now.
Yeah.
Like, how and why is it getting deformed so severely out in the water, down at the equator? Or we don't know
or
that.
somewhere between the equator and where it is today.
Correct.
Right? And we don't see coral. So, but let's just go with limestone in general. You know, it's warm enough that we've got carbonate-rich waters that are making
equatorial limestone.
Exactly.
That has gotten itself up here, and it was pre-deformed.
By the time it accreted, it was deformed.
By the time.
It's hard to associate that deformation with the accretion. The timing of the accretion.
That is so new. I don't think even when we were doing some of those alphabets, I really visualized massive collision between things way out in the water, except for maybe Alexander colliding with Wrangellia and Wrangellian friends. But this brings it all home that this complicated, deformed rocks in North America today that were not deformed anywhere close to North America. God bless America. I mean, Canada. I mean, something. Okay, so this is a winner. For sure we're doing this. And thank you, Jerome. And so now I wonder how much we talk about the intrusion. We don't know the age of the intrusion, really, or there's not much to say about.
Well, you can think of your candidate intrusive events in this region. We can start from that point, right? Yesterday we didn't film it, but we were in an area around Mount Washington and we saw Eocene age intrusive rocks.
Yeah.
That's too young. That's too young. So in this region, what do we have? We've got the Coast Plutonic Complex. And we've got other intrusive events that affect Vancouver Island a little bit earlier.
God damn. I'm sorry. I'm listening, I promise. But I'm also like, I'm going to cut you off, Jerome. Like,
no, go for it.
Why do we have alternating bands? Is this all limestone?
Well, it's limestone, and the black ones are a little different. They're extremely hard. They're more clastic. And there's variability. If you go to other bays that are still part of this limestone, there's less of these black bands. So these become more and more prominent in this particular area of the package of limestone. It's
the lighter gray that's more the pure limestone?
Correct.
And the blacks are a little churtier or something?
Yeah, a bit more, they're very hard, they're silicified, but I think they're more clastic, they're more mudstony, they have more clastic material.
So there's probably some of the Carmoutzen basalt is getting sandy or something on the surface.
There's an input or an influx of more clastic material. for, you know, we have no idea. It's all deformed, but it's very hard to imagine like the paleo geography of
Right.
what this submarine plateau looks like in its shallow parts, right? We'll have to imagine that there conceivably an influx of clastic material.
What
Correct.
did you want to? You didn't want to call this chert necessarily.
Yeah,
Light gray limestone interbedded with darker gray
yeah, more clastic layers.
plastic layers.
Plastic layers. I
Fine
think that's the
grained
best.
muddy layers.
Yeah,
Well, this is so attractive, and even from here I can
Yeah.
see these same guys totally swirled up again over here. Wow. If our viewers want to get here, are all your beaches public in British Columbia?
yes, they are, and anything below the high tide line is public access.
Okay.
And the real thing is accessing you have to cross over onto the beach, and there's public access points. So you can't walk on somebody's property just to get to the beach, but there are public access points. But once you're on the beach, it's all public access.
Do you want to share the name of this little point? Is that
This is an area called Open Bay. I think it's just there's a public access at the end of the road. It's all open to people. So yeah,
Open Bay is open?
Open Bay.
Green light for Open Bay. Quadra Island. Wow. This, I mean, come on, right into the intrusion.
Again, and I'm standing on some of it, and you're standing on a piece of it, but that one's obviously been deformed and dislocated. One of the things I like at this when you come with students is the thought of what does an intrusion look like, right? If you're thinking of intrusions, for many of our students and most people, what they think of is, that cartoon of like this mushroom or this big ball of red, orange stuff that's going to make its way through the surface. But this is when you see what an intrusion looks like, and a bit later we'll walk over to those points and you see it as well. But it's an explosion, right? It's injections of somewhat fluid material through layers, through fractures, and in areas there's a lot of it. In other places there's fingers that branch off of it. But it's really injecting itself wherever it can in terms of finding weak points.
I mean, I like this spot because I was literally looking down so I didn't fall. And I just imagined that I was just going to follow this to the water.
Yeah.
And then
Oops.
spladam. There's a
Yeah.
big roadblock. And this thing is likely connected to the one we saw
Oh yeah, absolutely, over
originally.
there.
Right. In fact, we can maybe mentally just kind of, that's what we were just looking at initially when we turned the camera on. And here's this squirt of granite.
But just on the question, is a good example here on the question of, the thickness of limestone and repeating. If you look at it here, there's folded material. If you didn't see the fold, my left foot's on the fold, we'll hide it for a second, you would just say, oh yeah, these are just beds of limestone.
Yeah.
But if you follow them, you realize actually they're part of a very tight fold that we call like an isoclinal fold, where the two limbs end up parallel to each other. So what we've done is sort of double the thickness of the stratigraphy through folding, right? It's kind of an artificial.
Right.
It's a layer this thin that we bend on itself and becomes double the thickness, but it's really because we can see the fold that we can say that. So here's the
little nose.
the nose and the axis of the fold is right down the middle.
Ha! How many geologists know about a place like this?
I don't know. All our students know about it now. A few people know, but
Like, is this in roadside of
no,
British Columbia?
it is not in the roadside geology book of British Columbia. I don't think so. There's people that have worked here, but there's a lot of interesting rocks and places, but they have to be. It's work to find them, right? And then it's work to decipher the story. But it's work to find those locations and
Well,
the places.
I don't know if I've ever seen a more aesthetic outcrop. I mean, this is just
Well, that's
super
a bold
cool.
statement, Gary.
It is.
That's a bold statement. That's like when people ask you, "What's your favorite child? Who's your favorite child? Which one?" You don't.
Okay.
They're all
I think it's
special in their
Open
own
Bay
way.
now. Today.
No, I did you just say I don't think I've ever seen a more exciting outcrop?
Yeah.
Yeah.
Like, I
A
think
more
I'm in that
attractive outcrop. And
and all I can just think of is this is what you see in Geology 101 textbooks, and here it is.
Yeah.
Like
But you see that in the 101 textbooks, but it's rare to actually go out and see it
Yeah.
right.
in person.
Well, in terms of cross-cutting relationships and different types of
Yes.
deformation, like folds and fractures and injections that are cross-cutting bedding and folded injections, there's multiple episodes or events that are captured in here. It's just,
Well, to say it a slightly different way, yeah, 101 textbook, 1984. Great, that's my beginning.
right.
And I'm just given a photo and a couple of terms and isoclinal and this is older than this. But no context.
Right.
No saying that these relationships developed at the equator.
Right.
I mean, that kind of thing. So
Yeah.
that's what feels new to this, where you can do two things at once. At least I think we're maybe going to try to do that in this episode. We're going to talk a little bit about the micro, Brady, but then before you know it, we're once again talking about global tectonics. My goodness. Is this a morning or an evening? Does it matter?
It's kind of facing south, so
Facing
I mean,
south.
a cloudy day like this is great.
Yeah.
What if it's a brilliantly clear day?
We go for it.
Anytime.
I think so, because if
Okay.
we're
Late
late
afternoon light's pretty good here. But,
Well, there's different. It's not like we have one cliff facing one way. I
Right,
guess,
right.
No.
We got different
We got
options.
options.
To
we
go
got
with.
options.
Even these blocks. My goodness. And tide level doesn't matter here, really.
a little bit, but not too bad. For this area, for these cliffs, it's not really above high tide, so you're okay for access. Yeah.
Now, so I'm looking at the barnacles, and they kind of
Yeah,
stop right
that's
here.
about as high as you're going to get. But for accessing these cliffs and up here, you're probably okay. I mean, any lower tide that's covered in seaweed anyways, you're not seeing anything.
Right.
So usually the tide is controlling whether you can get to the outcrop, and here it's not really an issue.
So it seems likely we're doing this one and we're doing the Nanoose Peninsula.
Yeah.
And in both episodes, we talk about this phantom Carmouthsen basalt,
Yeah.
which never makes an appearance, but is significant in both episodes.
Yeah.
We wouldn't have limestone if it wasn't for the Carmouthsen to build on.
Exactly. And we don't see the Carmouthsen here, but we would see, we saw some of it a while ago, and we could see a place where we see the relationship between the Carmouthsen and the limestone that overlies it. So that's not so phantom. The Carmouthsen is in the picture. We're just not seeing it in this
Not
outcrop.
seeing it.
Yeah.
In these two episodes, we're not seeing it, except from a distance yesterday morning.
Yeah.
That was Gary's instinct to point out that Carmouthsen's right over there. Maybe this is a trilogy, or I don't know, like maybe we do need a Carmouthsen episode separate. It's not like this is a series or something, but like, I don't know. The Carmouthsen is, if you're ranking geologic stories from your island,
Yeah. It's a big part of that story because it's aerially the biggest piece,
Yeah.
right? Most things are either built on top of, like this limestone, or intrude through it. So it's very central to that story.
So-
Insular superterrain, the main vehicle for everything that ends up in the insular is that submarine plateau
So,
of
like
Carmouthsen.
you're saying, the limestone developed on top of the plateau.
Yeah.
And then
There's
the Nanaimo formed on top of the.
The Nanaimo
of it
is on
also.
top of that.
Yeah.
And some part of it receives sediment from it. There's intrusive events, including some that might affect these rocks here, that intrude through it. The Carmouthsen, or the part of the Carmouthsen, is what, let's call it receives Silesia, or crescent. So it's a pretty central piece of all these stories over time.
Basalt on basalt.
Basalt on basalt, limestone on basalt, sandstone conglomerates on basalt, intrusions through basalt.
I just really excited about the intrusion coming up in through this limestone. I think
Okay.
that just being able to see that kind of right in cross section as you're just
Yeah.
walking right across it is just outstanding. And secondarily, all the folding of the limestone is fascinating. It's like, like Jerome was saying, how and where did that happen?
Good. Okay, we're not going to ignore the granite then. I thought maybe we were when we first saw this.
no.
You can't ignore that.
No.
The other thing for us, back to think about students. There's speaking of illusions, when you look at outcrops or vertical faces, it's easy to imagine that geology is two-dimensional. And this is just the fact that we have a vertical face, we have sort of a horizontal one, and we see the continuity, you realize very quickly this is three-dimensional plus time,
Yeah.
right? So, but the need to sort of think about that three-dimensional configuration is really becomes obvious in a place like here, because you have those different views at different angles.
That's a good point. That needs to be addressed before we sign off, to just go back and see that we don't have an outcrop. This isn't a road cut.
No,
This is a three-dimensional. We can film it from all sides and see this relationship. Thank you so much.
my pleasure. It's good. I'm taking you to all the best spots.
Yes, you are.